Welcome back. Today we will see the properties and the behavior or the requirements of stones as the building material. We will see the qualities required for a good stone first. The stone, like the brick, has got a minimum crushing strength. So for stone, which is naturally available or we are dressed to the required size and shape, they should have a minimum crushing strength of 100 Newton per mm square. This is the minimum strength required for the stone. It should have high resistance to wear and tear. The percentage of water absorption. So we have seen this for the bricks. So for stones, it should be after 24 hours. It should be less than zero point 0.6. It should have suitable texture for carving and dressing because as it's a naturally available material, we have to dress or like shape it into the required dimensions. So that's about it should have a suitable texture which will facilitate the dressing of stones. It should be durable. Yeah, it should have crystalline structure and the better appearance. It should have good resistance against the weathering agencies. So in a way, the stone should be easily should be able to dress in a effective way, as well as it should be resistant to the weathering agencies and should have medium strength. We will see the various classifications of stones. The building stones are obtained from rocks and they are classified into three ways. One is geological classification. So geological is the classification based on the origin of the rock. Next we have the physical classification based on the general structure of the rock, and we do have the chemical classification. They are the classification based on the predominant material available in the rock. So we will see in detail. First we will look into the geological classification. So they are classified into igneous rocks, sedimentary rocks, and metamorphic rocks. So this we already studied during your school days. We will see that the igneous rocks, they are formed by the cooling of magma. It can be like the granite, basalt, etc. as examples. The sedimentary rocks, the photo is given on the right side. Sedimentary rocks, they are formed by weathering action of the natural elements on the original transportation and deposition by any way like air, river, glacier, or sea. The example include laterite, sandstone, limestone, and the shale. This is basically by weathering action, it got break it into small pieces and then it settles to make the sedimentary rock. And next we have the metamorphic rock. The changing character of the igneous and sedimentary rocks under great temperature and pressure is called as the metamorphism. It's a process. So the stones which undergo metamorphism is called as the metamorphic rocks. So the metamorphism occur with various combinations of heat, uniform pressure, and the directed pressure. So examples include gneiss, marble, quartzite, and slate. So we seen the geological classification. Next is the physical classification. So based on the physical appearance. So they are stratified rock, unstratified rock, and foliated rock. In the case of stratified rock, they possess the planes of stratification. Rocks can split up along these planes. So an example is the sedimentary rocks, so because they are found by the deposition of the materials. And next we have the unstratified rock. So these rocks are not stratified. The structure may be crystalline, granular, or compact granular. The example include igneous rocks. And next we have the foliated rock. These rocks can be split up in a different direction, and they are called as the metamorphic rocks. Based on the chemical classification, there are siliceous rocks. In this type, silica predominates. The rocks are hard and durable. The rocks are not affected by weathering agencies like granite, quartzite, etc. So in this one, the silica is the major component. That's why siliceous rocks. So the argillaceous means clay. So in this type of rock, the clay predominates. The rocks are hard, durable, and brittle. Example: slate, laterite. Then we have the calcareous rocks. In this type, calcium carbonate predominates. Durability depends on surrounding atmosphere. The example includes limestone and marble. So we already seen the various type of stone or rock based on the classification. We will see what are the properties exhibited by these stones and how it will be useful for the construction purposes. So the basalt and trap, they are igneous rocks. They have a hard and tough property, and they are difficult to work, and its compressive strength is very high in the range of 150 to 185 Newton per mm square. And as it is not workable, we are generally used for road metal, rubble masonry, and the foundation works. The chalk, the sedimentary stone, they are the pure white limestone, and they are soft and they can easily form into the powder. So as we can break it or it can easily form to the powder, they are used in preparing the putty for painting purposes as the coloring material in the manufacture of cement also. Next we have the granite igneous rocks. They are hard, durable, and available in different colors. They are highly resistant to forces and can take polish. Its compressive strength ranging from 75 to 127 Newton per mm square. Their specific gravity is 2.6 to 2.7. They are used for steps, sills, facing work, walls, bridge piers, columns, rod metal, ballast, etc. They are unsuitable for carving. Next, we have the limestone sedimentary. They consist of carbonate of lime. They are easy to work and its compressive strength is 54 Newton per mm square. The specific gravity is 2 to 2.75, and they are used for floors, steps, walls, rod metal, manufacture of lime in blast furnaces, etc. It continues. Marble, metamorphic. They can take good color and polish. Its compressive strength is 71 Newton per mm square. and the specific gravity is 2.65. They are used for flooring, face work, columns, steps, ornamental work, and they can be easily carved and sawn. Next, we have the laterite metamorphic rocks. They are porous and spongy structure, are easily quarried in blocks, contains high percentage of iron, available in different colors. Its compressive strength is 1.8 to 3.1 Newton per mm square, and they are mainly used as the building stone, wrought metal, and for the rough stone masonry work. So we will compare the quality requirements of a good building stone. The building stones used for the face work, that is facing work, which is shown to outside of the building, should have a fine, compact texture. The stone, when broken, should not be dull in appearance, and it should show uniformity of texture. The stones used in construction should be strong and durable to withstand the disintegrating action of weather. When stones are utilized as for making the floors, pavements, aprons of bridges, and other purposes, it should have enough resistance to the wear and friction. When the stones are supposed to undergo vibrations of machinery and moving loads, they should be tough. The stones are said to be workable if the work which is involved in the cutting, dressing, and shaping is considered as economical and easy to conduct. The building stones should be free from calcium carbonate, oxides of iron, and minerals having different coefficients of thermal expansion. Okay, now we will see the property of the cement, because cement is one of the main component in the making of concrete. Okay. So the cement is a product obtained by burning a well-proportioned mixture of siliceous, argillaceous, and calcareous metals and crushing the same into fine powder. So it is a combination of siliceous, argillaceous, and calcareous metal and processed in a defined way to make the cement. The mixture of siliceous, argillaceous, and calcareous materials must be burned at 1400 degrees Celsius. So these are made in at a temperature of 1400. The clinker is a material which is obtained after heat treatment at this temperature, and the clinker is obtained and cooled and powdered to the required fineness. Then the product so obtained is called cement. That means the clinker up to the clinker sorry, to the clinker, we will add some more materials to make it into the cement. So the cement is considered as the most inevitable material for the construction purpose, and the calcareous and argillaceous material should be used in the ratio 4:1. So for 4 kilo of calcareous, we have to use 1 kg of argillaceous material. And the calcareous material we are using is calcium carbonate, and argillates are the clay material. And normally the product cement is available in the packets of 50 kg. We will see the various properties of cement. There is the even cement is also having in various types. So one type is the ordinary Portland cement, and we will see the physical properties of the cement. The color of the cement should be uniform. Is having a gray color, and all the cement particles inside the cement bag or whatever we are using should have a uniform color. The cement should be free from lumps. Lumps means formation of small uh, groups of that means a group of cement. materials may get clubbed together to form the lumps. So it should have any lumps. The cement should be uniform when touched, and the cement should be cool when felt with the hand. If a small quantity of cement is thrown into a bucket of water, it should sink. The average compressive strength of cement mortar cube of side 7 centimeter should be less than 11.5 Newton per mm square at the age of 3 days and 25 Newton per mm square at the age of 7 days. That means we already seen the compressive testing of the cube. So we will make a uh, cube with cement mortar. That means cement mortar means only cement and the cement sand and water. So we'll make a cube of cement mortar cube, and its strength will increase as on the days are getting increased. So at the end of third day, the minimum value required is 11.5, and at the end of 7 days, it should have a minimum strength of 25 Newton per mm square. The average tensile strength of cement mortar should not be less than 2 Newton per mm square at the age of 3 days and 2.5 Newton per mm square at the age of 7 days. That means this is the compressive strength. So what we talked now is regarding the tensile strength. Continuing, the heat of hydration should not be more than 75 calorie per gram after 28 days. That means the amount of heat generated should not be more than 78 calorie per gram after the 28 days. The initial setting time of cement should be less than 30 minutes, and the final setting time should be around 10 hours. So that means initial setting means when we apply water to the cement, it should not set instantly. So that's why we have already seen that after the heat treatment we will get the clinker. So to this clinker we will add a gypsum material, and this gypsum material is responsible for delaying the setting time of the cement. So if the clinker is directly, that means the water is poured directly to the clinker, on the instant the clinker will get set. So when we are adding gypsum to the clinker, it makes the cement, and even we add the water to the cement, it should not it will not set before 30 minutes, and the final setting time should be around 10 hours. Final means getting hardened time. This is just set time, this is getting hardened time. The fineness of the cement should be less than 10 percentage in the sieve test. The fineness test is done in this mount. So we will, this is cement, and we will pass the cement through this sieve, and if 90 percentage of the cement passes through the sieve, then it's fine. So that's what this 10 percentage sieve is. So only 10 percentage can, only up to 10 percentage can remain on this mold. That means uh, only 10 percent is coarser compared to the total material. So that's about the fineness of cement. And soundness test, here we have soundness testing apparatus, and we will fill the cement mortar, that means cement plus, not cement mortar, cement plus water, and we will mix, and we will apply the cement mortar, yeah, right, cement mortar, cement plus sand plus water, we will make a cement mortar, and we will fill into this one, and we will kept it idle for say 1 day. And you should know that the cement mortar get expand as the age days are ongoing. So after 1 day, If the cement mortar inside this mold getting expand, these two parallel uh, this parallel part, right? This should get expanded. So this expansion or this gap between the two parallel parts should not be more than 10 mm. If it is more, that means the quantity of expansion or the amount of expansion is more. It's about soundness test. And we have some chemical important elements. The ratio of percentage of alumina to that of iron oxide should not be, so it should be more than 0.66. The ratio of percentage of lime to those of alumina, silica and iron oxide should be between 0.66 and 1.02. The total sulfur content should be less than 4 percentage. Now we will see in detail the cement production process. This is the complete set of figures. So on the raw mill, we will mix silicon, calcium, iron and aluminium, and it is passed through the electrostatic precipitator, and it is stored in the silos. From the silos, based on the requirement, it is passed to the rotatory kiln, where which we are applying the temperature. Okay. So this electrostatic precipitator, they are used for filtering device that removes the fine particles like dust and smoke. So we brought the material to the rotatory kiln, and this kiln is heated up to very high temperature. Say we already seen that it is at 1400 degrees Celsius minimum, and here it is heated at the temperature of 2000 degrees centigrade, and then we will get a clinker at all. So this clinker, when we add water to this clinker, it will set very quickly. So we need some timing for setting. I mean, when we do construction processes, when we apply the water, it should not set instantly. So for those purpose, we are adding the gypsum, which delays the setting time of the cement. And when gypsum is added to the clinker, we will get the cement, and the cement is stored in the huge uh, silos, so huge, huge vessels, and then they are based on the requirement. They are taken to the packing house and they are transporting to the required places. So to transform the clinker to cement, we have we are doing some grinding process. We are adding the main component gypsum. We can add some coal. This is called coal fry. It is called fly ash, and blast furnace slag. It is for the economical manufacture of the cement. That means this blast furnace slag and the coal fly ashes will replace some quantity of the clinker. Okay. Next, we will see the setting time of cement. It's an important thing. So I told the setting time of cement should not be less than 30 minutes. So we will see how it is testing. So we have an apparatus called as the wicket apparatus. When you see the wicket apparatus, this is the main apparatus. You have a mold where the cement paste is filled. You have a needle or angular here. So its enlarged view is shown here, and you have a glass plate where on which the mold has to be placed. So on this apparatus, we'll first place this glass plate. Then we will place this mold. Then we have the plunger or needle is attached here. So this should be attached here. So we will see how it is done. For okay, so this is a mold. So mold, in this mold we will add the cement plus water, and then we will place it on this apparatus above this glass plate, and then we have two things. So the first needle is used for finding the initial setting time of cement, and the second one is used for finding the final setting time of cement. Initial is 30 minutes and final should not be more than 10 hours, as I told. So First, we will use this needle and we'll fix here, and we will remove this lock. So this will plunger will go into the mold. So when you do it at the instant, the plunger needle will touch at the bottom. Okay. So when you repeat the process at different places, at some time, as the time passes by, maybe after around 30 minutes or 30 minutes more, the plunger, that means the bottom portions may get set. That means the plunger won't penetrate full into the mold. So as the setting started, so this portion may got settled, and the plunger won't go below this point. So the time required for the needle for not to go to the last 5 to 7 mm depth is taken as the initial setting time. So the time period elapsing between the time water the time period elapsing between the time water is added to the cement and the time the needle fails to pierce the test block by 5 mm measured from the bottom of the mold is called as the initial setting time. So now it's clear. The time required for the needle not to penetrate for this depth. Similarly, for the testing of final setting time, the period elapsing between the time water is added to the cement and the time needle makes an impression on surface of the test block while the attachment failed to do so for final setting. That means we are second case we are attaching both the sharpened needle and this attachment. That means with an anvil attachment. So when you are using both needles and you are simultaneously unlocking the same, if it is final setted, that means this will make some impressions on the surface and this anal attachment will not make any impression. So initial time the both will make some impressions. So maybe after some time, that means after the cement got final setted, this will make an impression. The angular ring won't make an impression. So that is the final setting time. So both are doing in the wicket apparatus. We will see the various types of cement. So we already seen the properties of the ordinary Portland cement. They are the commonly used cement, and the ordinary Portland cement are classified into mainly three types: C33, 43, 53, based on the cube strength. So the grade is the average compressive strength of modern cubes at 28 days when tested as per the Indian standards. So C33, the compressive strength after 28 days is 33 Newton per mm square. So if the cube made by the cement exhibits a strength of minimum 33, so minimum it's like maximum 33, then it is called as the C33 grade cement, and they are generally used for the general construction works, and they the use of this cement is very much reduced, no, not frequently used C33. And the C43, they are the most widely used cement for construction works like residential, commercial, industrial buildings, roads, bridges, and flyovers. So their strength should be after 28 days, it should be 43 Newton per mm square. It's suitable for all applications like reinforced cement concrete, plastering, and masonry. And next we have the C53. The minimum compressive strength should be 53 Newton per mm square. It gives 10 to 15% saving in the cement consumption and 5 to 8% saving in the steel consumption provided by the higher grades of concrete are used. They are high strength cement and they are used for high rise buildings, flyovers, chimneys, and the other main important structures where the high grades are required. Next, we have the colored cement. They are obtained by mixing mineral pigment with ordinary cement, like chromium. If you add, it will give a green color. and the cobalt will give you a blue color. They are used for finishing of floors, external surfaces, and windows. This type of cement is the expanding cement, and they are obtained by adding an expanding medium like sulfur aluminate. This cement expands, and they are used for construction of water-retain structures and repairing the damaged concrete structures. Next, we have the high alumina cement. As the title itself, this cement is having more alumina content. They are produced by grinding bauxite and lime along with the clinkers. Bauxite is an ore of aluminium. The initial setting time of high alumina cement for this type of cement, the initial setting time is more than 3.5 hours compared to 30 minutes for the normal cement, and the final setting time is less. So that means this cement will having higher, like larger initial setting time, and they will quickly set. That means final setting is more quick compared to the normal cement. So this will facilitate more time for the mixing and placing operation. It cannot be used for the mass concreting as it involves more heat. Next is the low heat cement. This type of cement is used to reduce the amount of heat generated during the setting. Contains lower percentage of tricalcium aluminate C3A of about 5% and higher percentage of tricalcium silicate. This possesses less compressive strength, and they are mainly used for mass concrete works. And next we have pozzolano cement. This type of cement is obtained by adding pozzolano, which is a volcanic powder. The percentage of pozzolano material is between 10 to 30. It evolves less heat during the setting and imparts high degree of water tightness, plasticity, and workability. It possesses high tensile strength. Next, we have the quick setting cement. This type of cement is obtained by adding aluminum sulfate and by finely grinding the cement. The percentage of gypsum is also greatly reduced, and the setting of cement starts within 5 minutes. So it's quickly it will start to set, and it becomes hard like stone within 30 minutes. So both the initial and final setting time is quick in the case of setting cement, and it is used for the underwater construction. That means we don't have much time, because for underwater construction we need to uh, empty the water from that place. So we can't hold the water for a long time. So that's why we are going for a quick setting cement. Continuing, eighth one is the rapid hardening cement. This cement contains 56% of the tricalcium silicate C3S. It attains high strength in early days, but the initial and final setting of cement are the same as those of ordinary cement. The structural members constructed with this cement requires short period of curing and can be loaded earlier. Next, we have the sulfate resisting cement. It is a cement with low C3A content and comparatively low C4AF content. This cement is used in the construction of structures that are likely to be damaged by alkaline conditions such as canal linings, sewage treatment plants, and the marine constructions. Next, we have the air entraining cement, because by air entraining into the cement, it will facilitate easily mixing of the cement. So 0.01 to 0.05 percentage of air entraining agents like benzol in wood resins directs are added during the grinding process cement manufacturing. The concrete made of this cement is more plastic. Workable means it can be easily mixed, and it causes less segregation. Segregation means the concrete is made by the proper mixing of cement, sand, metal, and water. Segregation is that means the concrete should be homogeneous. Is made by proper uniform mixing of sand, cement, and the metal. Segregation means maybe the one part, the cement or the metal can get accumulated in a single space, and the cement can accumulate in a different space. It is called segregating the materials inside the concrete. So this is avoided in the case of proper mixing, and this will be can be done by using the air and training cement and the resistant to the freeze and thawing action. We see the various uses of cement. They are used for making concrete, for laying roof, floor, and other construction of the beams and columns, for lintel, stair, foundations, etc., and for making the mortar for the brick masonry, stone masonry, etc., for construction of important structures like dams, bridges, water tanks, etc., for construction of roads, runways, wells, posts, etc., and for manufacture of precast structures, pipes, etc. So we'll stop for today.